Hello and welcome everyone to our next lecture. In this lecture, we are going to discuss about linked list. Linked list is a type of data structure in which we store the data, and with the data, we keep the pointer to the next variable. What this next variable does, it stores the address of the next data in the list. So the next data will be stored to this address. So how it is different from array? We can see in arrays, the data we create a memory of exactly the size of the data which we are going to store, and it is all a continuous memory allocation. This all blocks are contiguous memory locations, but in linked list it is not the case. In linked list, the next value is connected with the previous value via a link node. That link node contains the address of the next value. So whenever we store a data, the benefits of a linked list is when we store a data, first of all, we do not need to define the exact size that we are going to require, because we can create another node and just connect it to the end whenever we want to add another data. That's why it is beneficial over an array in few of the cases. First one is adding or removing any data. So whenever we want to add or remove any data, what we can simply do, we can remove this node and point if we want to remove the center one. So we will simply make this next value connected to this node, which was previously connected via the second node, but in this case we have removed the second node. So we will remove this connection and point the previous connection to the next connection. So in just a few of the changes, this will take order of one time to change, add or remove any value if we are pointing to that value. Say if we have the location of this node, we are at this node, then the removal is O of one time. But if we are not at this node, then we will see what is the difference. Adding or removing is easy, and we do not need to define the size we need. We only need to define a node that will contain the data type and the next pointer, and every time we want to add, we can in the fly simply add it. As we have seen what a node does and what it looks like, let us talk about the demerits of a node. In node, to reach any value, say we want to reach to this fourth node, there are more nodes here and so on. So if you want to reach here, in a linked list, we only have the value of the first pointer, the head node, we call it as head node, and then we have to iterate from here. So in first jump we go here, in the second jump we go here, the third jump we go here, and then we find our node. So a search operation is order of n at worst case scenario. In the case if you want to find the last node, we will have to traverse all the data and then we will reach to our required data. So searching is order of 1, adding, removing is order of 1. So that is linked list. Let us see how a node looks like when we define it. Template, type name, object. So we have given an object type name. Now we will give a class of node. So private will be two values. First one will be object value name. So it will be contain the value which we are going to store, and node star pointer that is equal to null initially. Now public, we're going to define the node constructor object value, we are passing it. So this value, which is this value, so it is pointing to this, will now be equal to value. So what this value is? This value is coming from here, which we are passing in the constructor. So this will be like this, and the pointer ptr is equal to null. We will have to externally define the pointer. Now node has been defined, so the node is actually the single node. It is not the linked list, complete linked list. Now what a complete linked list will contain? First, it will contain head in the data, head pointer. Head pointer will point to the head of the node, head node. Then a constructor. Then constructor will be there. Then different data types, different functionalities such as adding, searching, removing. These three we are going to define, and print also, print function also. So let us see this in our code. First we are going to define our class, node class, with use of template. Now as we have used the template, we will define a class and give it a name of node. In this node, what we are going to store is in object value, and the second will be node pointer next. That is whenever. Now node constructor, this will, we will pass the value. Okay, so this value will take the value from val, and next will be defined as null pointer. Null pointer, it will point at null value. Now once we have done this, our node class has been defined. Let us look at the linked list class. So we will copy this in linked list class. In the private, we will contain node pointer head. That is, we will define it here. Now once we have done that, when we define linked list, what we need to pass is the node pointer head to it. So this head will take the value from head. Or if we define like this without any value, so what will happen? A node pointer temporary will be a new node pointed new node with data of say 0. Now this head will be equal to temporary. So both the cases we have covered. In the first case, we are passing, when we are doing the constructor, we are actually passing the head node, but in the second case, we are not passing any head node. Let us define the print function. So the print function will basically iterate to all the values and will print the required nodes. So how it will do that? First, let us take a temporary node, or say name it as runner, because we are going to run it, is equal to this head node. Now as a runner has been defined, let us see how we are going to iterate to all the values. To iterate to all the values, what we are going to do is we will take a head node. We are given head node. Now we will create a copy. This is our head node, HEAD. Now we have created a copy of head node which is pointing to the same node and named it as runner. To loop everywhere, what we are going to do, we are going to make runner is equal to runner next. So every time we want to jump, we basically do the task of runner jump. Runner is equal to runner next. So this is the value of runner next, which is pointing here. Now the runner is currently pointing here. When we do this step, it will now point here. So the runner has come to this point. Now, as we want to make this loop, till where this loop will go, this loop will be continued till we reach a null value. So here it is a null value. So now our runner is here, while runner is not runner is equal to true. So null pointer is actually false. When runner becomes null, it will become false and it will break out. So what it will do, it will iterate till the runner is there and it will see out runner this dot. What is the value we are saying? So value is the name, runner dot value will be printed. So this is the way we are going to do the print function. So now let us define a function, define add node. In this, what we are going to do, we were going to pass object value. What this object value is, this is actually going to be the value we are going to add. So every time we want to add, what we will do, we will have to iterate till the end. So node pointer runner is going to be this head, while runner next is true. When we are at 1, the runner next will be 2. Then at 2, runner next will be 3. When we are at 3, the runner next will be 4. But when we are at 4, the runner next will be null. So while runner next is true, we are going to iterate. And when we come here runner next is equal to null. So it will break out. So runner. Okay, so in the print function, we forgot to do runner is equal to runner next. What we are doing here, we are just changing the runner every time. So this is the way we can do it. Add end. So this is the way we add something to the end. If we have the tail, then we can easily, without doing this, just add the value to the tail. Now let us see how we are going to do this add beginning function. So in the add beginning function, say this is our linked list. When we want to add anything to the beginning, what we're going to do, we create a node and make it as any temporary node, say. So temporary next will be pointing to head node, and then head will be replaced to this node. So this will become our head node, and by this easily we can add to the beginning. So adding anything to the value is very easy. We create a node, say node pointer temporary is equal to new node with value of value, and temporary next will be equal to head pointer. And now head, so head is this head is equal to our temporary node. So the temporary is now going to become the head node, and thus we have added anything to the beginning. Now the next function is remove function. Say we want to remove any value from the array, the linked list. How we are going to do this is, so for example, we are going to remove this node. Say we are here at the head node. So head node is here. We will first iterate till here. We will keep the value of the previous one in the previous and the next one in the next variable. We will name it as such. Now what we want to do, previous will point at next. So previous next will be equal to next. Simply by this way, this connection has been broken and this is now pointing here. Now we will delete this node which we have passed. So hopefully that was clear. So till we get the value, first we have to create a node, named it as head temporary is equal to head node. We are at this dot head. So while our temporary is there, temporary is going to be our node. While this is true, we will iterate if temp data. So we have to, as we said, we have to create two more pointer. Previous is going to be null, and next we do not need next. If temporary data is the data required, it is actually equal to the value. So not data, the value of temporary is equal to the value. Then we have found our node. Then previous next will be equal to next. Or now we have not created next pointer yet. So node pointer next will be equal to temp next. So basically what we are doing, we are creating a next pointer that is equal to temporary's next pointer. Return and delete our temporary. So yeah, we will delete our temporary. Else, if this is not true, what we are going to do, then we will make simply previous is equal to temporary and temporary is equal to next. That means we are iterating forward. Either we cannot return anything or we can return a boolean value just to define that yes, the value was present. If it is true, then the value was present. If it is false, then the value was not present. So this is our remove function, add, and all the functions we have now implemented. Now let us create a linked list here of type integer and name it as L, just say L. So L dot add begin. So here we have not covered the base cases. If head pointer is equal to null, that means we are not having any data. In that case, we are simply going to create a node, and then this head will become temp. We're not going to do this step because we don't have the head step. In the add end also, we need to check the base case. If head equal to null, okay, null. So head here is this head. If that is equal to null, then we are going to just create a blank node here. Node is equal to new node with the value, and then head will point to the runner. So this was the base case, we covered it. Now let us define add.begin 1. Let us say 2, 3, 4 and 5. Print, and now check it. So as we have made it as a template, we need every time to define that the data type is going to be object here also. We need to add public here also. So there were few mistakes that we have done. Firstly, this was a node, so whenever we are calling it, this was created with a template. So we need to define the data type every time. So by defining this node with the object as a data type, that was the correction. And secondly, there was a minor mistake in this add begin function of spelling mistake of object ob. So after rectification, after clearing everything, let us see. So when we are adding at the beginning, what is happening? That first one is added. Let us see here. When one is added, we are adding 2 at the beginning. So now 2 will be one, the first point, then 3, then similarly 4, and then similarly 5. So when we are going to print, we are going to print from 5 to 1. So this is the value. And one more thing, this is printing 0 also. The reason behind is, when we are defining our constructor, when we are defining our linked list, it is pointing to a node with 0 value. We just remove that, and now in that case, what is happening? This head is equal to a null pointer. Once we add this, we need to return, because it will do the same task again if we won't do that. Here also we need to do return, else this will execute this part also if that case is passed. So now clearing everything and checking, we can see 54321 is the exact output which we are getting. Now, apart from adding beginning, let us use the add end function. So it is going to be 1. In this case, as we are adding to the end, it will get printed to the correct order, in the correct order, 3, 4 and 5. So we save it and run. We see the output is 1, 2, 3, 4 and 5. So this is giving the correct output. Let us test our remove function. L dot remove. What we're going to remove is 3, and this print function, let us call it this. So in this case, what will happen? 3 will be removed, and we should get only 5, 4, 2 and 1. Oh sorry, 1. This was the right 1, 2, 3, 4 and 5. It was printed like this. Now 3 has been removed, so it is printing 5. Now let us try and remove last value or first value, and also the last value. So the first value is 1. Now try to run it. So it is giving error. Let us check what mistake we have done in the base cases. So we haven't tested for the base case, that is, if we only have one value. If not of head, simply return and do nothing in the case in which head is not null or not a value. We have to put this block in the test case, because if and only if previous is present, then put previous is equal to next. Else, if previous is not present and temporary, we have found the value, that means we are at the first value. So this head will now be temp next. So what will it do? Head will shift to the next value, and we will break the head next pointer. This head next pointer will be null, and now head will be temp next. So now temporary is equal to the second value. Head will take that value. Sorry, we have already iterated temp to the next value. We have removed head pointers, head's next pointer, and now we will point the head. So we are getting 2 and 4. Hence, this is the correct output. And that's the way we have implemented our linked list. Thank you. Keep learning, and please don't forget to like, share and subscribe.